Hello, everybody. Here we are, 4.1 and 4.2 applied problems. These are the word problems. So far, we've just done kind of the theoretical stuff and nothing applied. And so I wanted to do it all together. 4.1, as you'll recall, is about square roots and cube roots. And 4.2, we've been spending a lot of time on integral exponents. So that's our positive and negative exponents. And so here are some word problems. There's some from 4.1 and some from 4.2. And in the textbook questions, I'll get you to do both. So let's start. Number one, the Henderson family plans to build a square double garage. The floor plan shows that the garage will have an area of 576 feet squared. What are the side lengths of the garage? So even though it says it's a double garage, we're just going to, assume it's a square. We know a square is a special rectangle that all the sides are the same, and it's given us the information that the area is 576 feet squared. And so to solve this, you'll need to recall the relationship between the area and a side length. That the area is the side length squared, and that the square root of the area gives you the side length. So we currently have the area, 576. And if we take the square root of that, it'll give us the side length. That's what we're after. So let's go. 576 square root equals 24. And this is feet. And that's it. Just wants to know the side length of the garage. The garage is going to be 24 by 24. There you have it. Next one, right prism is shown. I feel like the lengths, visually the lengths are a little bit off. I would say maybe this is 3 meters, maybe this should be 8 meters. What would be the dimensions of a cube with the same volume? Okay, so we want to know what would be the dimensions. So we got a cube, and we want to know not just one side length, but all of the side lengths. Those are the dimensions. And we want it to be the same volume as this right prism right here. So let's figure it out. We first need to find the volume of this shape. And you recall that volume equals length times width times height. Doesn't really matter what order you go in, width times length times height. This box, if you can imagine it, could be on any of its sides, flipped up this way or flipped up a different way, and it would still take up the same amount of space. So the volume equals, 9 times 3 times 8. And see where that gets us. 9 times 3 times 8, 216. It's meters cubed. Okay, great. So I've done the first step. I figured out the volume of this, 216 meters cubed. And now what would the dimensions be of a cube with the same volume? So we know, say, that the volume of this cube is now also 216 meters cubed. So what would be the side lengths? Well, we can figure that out just as, you recall that the area, the square root of the area gave us, square root of the area of a square gave us the side length. The cubed root of the volume of a cube will give us its side length. So the cubed root of 216, or the volume of the cube, would give us the side length. We can do this in our calculator. 216, and cube root equals 6 meters. So now we figured out one of the side lengths of our cube. Beautiful. But the question has asked, you'll recall, for the dimensions. So it wants not just one side, but it wants all of the sides. And remember, it's a special kind of shape where all of the sides are the same. So 6 meters by 6 meters by 6 meters would be the dimensions of this cube. Our answer is right there. Okay, beautiful. And you could check, you do 6 times 6 times 6, you'd get 216, and you could check, okay, I did that right. You could check if you would like. One of the things, number three, one of the things I need to assess you on is your ability to communicate your mathematical understanding. So here's a question that I think is good to demonstrate that. And there could be many answers to this, but I'm looking for one that makes sense, is coherent, etc. So why does the square root of negative 25 have no solution, but the cubed root of negative 27 does have a solution? Well, this shows that you understand what a square root is. A square root is saying what times itself equals negative 25. And there are no positive number multiplied by itself can make a negative number. Nor can any negative number multiplied by itself. So you can't do a positive times a positive and equal a negative. It just doesn't work. And you can't also do, a negative times a negative and equal a negative. That also doesn't work. So we can't have any number multiplied by itself to equal negative 25. But cubed roots, as you know, what number times itself 3 times can equal negative 27. And so you could say there is a number, negative 3, that when multiplied by itself 3 times equals negative 27. So that's why it has a solution, because a negative times a negative times a negative can equal or does equal a negative. And maybe it'd be easier actually if you wrote negative like this, neg times negative equals a negative. That might be a little bit easier for your notes. These next questions, I think those ones were all 4.1, and this is 4.2. So these ones are dealing with our positive and negative exponents. And these questions, for the most part, give you the formula. And so I think often making your own formula can be quite difficult. And so, and I think all of the questions, or most of the questions that I've given you, they already give you the formula, which can be really helpful. So a radioactive element has a half-life of 1 month. The amount of element remaining is given by the formula A, or I guess amount, sure, equals 400 times a half to the power of n, where n is the number of months. Today there are 400 grams of the element. How much will remain after 4 months, and how much was there 3 months ago? Okay, so n is the number of months. It's a very important piece of information. This formula is a very important piece of information. And here what we have to answer is, of course, also very important. So we just need to input the information that we have into our formula. So let's solve A right here. How much will remain after 4 months? So we're looking for the amount equals the 400 grams that we have times a half to the power of the number of months, which is 4. And now we can solve. A equals 400. A half to the power of 4, you can distribute this 4 inside. So it become 1 to the power of 4 and 2 to the power of 4. So we get 1 over 16. And so A equals 400 times 1 over 16. 400 times bracket 1 divided by 16 bracket equals 25 grams. You could ask yourself, does that make sense? Radioactive element has a half-life of 1 month, so it halves halves itself every month. So after 4 months, the first month it would go down to 200 and then to 100 and then to 50 and then to 25. So yes, that makes sense. Okay, it's going down, it's getting smaller. And the next one asks us, B, how much was there 3 months ago? So we're moving in a different direction. We now have the amount equals still 400 and still a half. But what do you think we do 3 months ago where n is? So n is the number of months. I think we could say it's reasonable to guess it's going to be negative 3 months. So 3 months ago. And now let's solve this. We get amount equals 400 times a half. Well, let's not do a half, actually. Remember, when we have a negative exponent, we can flip the base. So let's do that. We're now going to, instead of 1/2, have 2 to the 1, now to the positive 3. And we can distribute the 3 inside. And we get the amount equals 400 times 2 to the power of 3. We 8 over 1. And now we just have 400 times 8. 400 is going to give us, 3,200. There you go, 3,200 grams of the element. And does that make sense? Yes, 3 months ago we had even more of this, and then it halved to 1,600, then halved again to 800, and then halved to 400. So there you go. I think it's good to ask yourself, just like in any math question at the end, does it make sense? Let's do the next two. I think I got 2 more. Yeah, 2 more. So the next two, the formula D equals a half times G times T squared can be used to determine how long it takes an object to fall a certain distance from rest. In the formula, D is the distance in meters the object falls, G is the acceleration due to gravity, so 9.8 meters per second squared, and T is the time it takes in seconds to fall. This is, I feel like, a very physics type question. So express each answer to one decimal place. Let's do it. So A, from what height does a penny fall if it takes 12.4 seconds to reach the ground? So we have our formula. Distance equals a half times G, gravity. They give us this right here. So that's not an unknown. We can substitute that in there. We know as well the time. We know the number of seconds, but it's from what height. It's the distance that we're looking for. So distance equals 1/2 times 9.8. I'm going to not have brackets. Half times 9.8 times 12.4 squared. Okay, let's do it. I'm going to do distance equals a half 9.8, and let's do 12.4 squared. 0.4 squared, 153.76. And now we can just solve left to right. Distance equals a half of 9.8. 0.5 times 9.8, 4.9. 4.9 times 153.76. You could have done all of this, honestly, from the beginning in your calculator. Just make sure that you're, using all your brackets right, so that your calculator is really smart, but sometimes can get mixed up about the order of operations. So 4.9 times 153.76, 753.4. And I think the distance is in meters. So 753.4 meters is the distance that the penny falls from if it takes 12.4 seconds to reach the ground. And now let's do B. So how long does it take the penny to fall from a height of 28.5? So this time we have the same formula. We know now the height. So we know now this part, the distance. We still know this part, the the G, but it's the time that we don't know, okay? So let's go. We know the distance, 28.5 equals half. Okay, I got cut off, but I was saying that the distance is 28.5 meters, and half times G we know is 9.8. And it's the time that we're trying to figure out. So we can leave that as a t squared. So this time I'm going to solve this part first. We want to get the t by itself. In our last one, I think we did that. We had 28.5 equals a half of 9.8 is 4.9, and still to t squared. We want the t by itself. It's currently being, there's a little invisible, you can't see it, it's a little multiplication there. So we want to divide by 4.9 to get the t by itself. What we do to one side, we have to do to the other. Let me scroll up. So now this becomes a 1. We're left with t squared equals, let's do that in my calculator, 28.5 divided by 4.9 equals 5.816. So 5.816 equals t squared. And we want t by itself. We don't want t squared. So we need to do a common final step in math. We're going to take the square root of each of these. Remember that taking the square root of a square cancels that out. We'll be left with t, or time in seconds, equals the square root of 5.816. So let's do it. Square root 5.816 equals, I feel like I did something strange here. Not what I was expecting, but let's see. I was expecting, you expect at least 2. So what have I done here? Where's my calculator? Square. Oh, I think we go 5.816. There we go. 2.4. 2.4 seconds. So I mean that's a good example of, ask yourself what you're expecting. I mean the square root of 4 is 2, so I was expecting a little bit over 2. I think I just pressed it into my calculator in the wrong order. So anyways, there you have it. The time is 4.2 seconds. Remember to put your answer in the unit that we're after. This was asking for a distance, so I want to know that it's meters. This is asking for a time, and I want to know that it's seconds. Let's do the last one together. A culture of bacteria in a lab contains 400 bacterium cells. The number of cells doubles every hour. This situation can be modeled by the equation B for bacteria equals 400 times 2. That's the doubling to the power of the hours, where B is the estimated number of bacteria and H is the time in hours. So how many bacteria were present after 3 hours, after 24, after 3 hours ago? So same as the one we did a little bit above. So let's just use our formula and put in the information. So for A, B equals 400 times 2 to the power of 3. Bacteria equals 400 times 2 to the power of 3 is 8. So the number of bacteria equals 400 times 8, which I know to be 3,200 bacteria. It's in bacteria, so I don't think we need to use a unit. I think that it's a unit itself. And that's just 400 times 8. That's how I got that. Let's do B. This is going to be much more. Now we have the number of bacteria equals 400 times 2 to the power of 24. 2 to the power of 24 is much bigger than 2 to the power of 3, and we're going to end up with a much bigger number. So let's see. Let's see. 2 to the power of 24 equals, there you go, 16,777,216 times our 400 bacteria. Okay, 6, 7, 10. So B. 886, 400. So it can quickly get out of control. This is why, food safe is very important. If you have a certain number of bacteria in your food, it can easily get very out of hand. And let's do the last one. Looks like, 3 hours ago, it's going to be a question where we're using a negative exponent. So number of bacteria equals 400 times 2 to the power of negative 3. So there we go. Bacteria equals 400. And now remember, we're going to reciprocate our base. So it's 2 over 1 will now become 1 over 2 to the power of positive 3. And we can distribute this 3 inside. We get bacteria equals 400 times 1 to the power of 3, which is just 1 over 2 to the power of 3, which is 8. And 400 times an eighth, 400 times bracket 1 divided by 8 equals 50 bacteria. So there you go. Thank you very much. I'll let you know what textbook questions I'd like you to do.